And welcome back. It's the 14th of June, higher plus 5 a day. And let's just go straight to the first one. Okay, so we have right. It's going to be a non-calculator question, couldn't it? So what it wants you to do is it wants you to remember that 32 is the same as 2 to the power of 5. And the square root is the same as 2 to the power of a half, which means I can write this as 2 to the power of 5 over 2. And actually that's question done, isn't it? So I've written it as 2 to the power of x. Okay, first bit done. Next bit. 8 to the y plus 1 equals root 32. Now, interestingly, I believe I'm going to use the thing I've just worked out. Yes, I am. Okay. So 8 is the same as 2 to the power of 3. So I've switched my 8 for a 2 to the 3. And then I'm doing that to the power of y plus 1, where the whole thing is to the y plus 1. And 2 to the 32 I've just worked out is 2 to the 5 over 2. Now, because the base value is 2 in both cases, it must therefore be the case, let's do this over here, that 3 times y plus 1, which is 3y plus 3, is equal to 5 over 2. You don't have to do this next step, but I like to do it just to make it slightly easier. So multiplying it by 2, which gives me 6y plus 6 is equal to 5. Take away 6 from both sides means that 6y is equal to minus 1. And finally, answer the question, the value of y is minus 1 over 6, or minus a sixth. And then it's first question done. Next question. Wow, okay, lots of words. Key to this question is to read it all through carefully, and I tend to make some notes as I'm going. So I'm going to highlight it as I go. So class 10D makes some cakes using milk chocolate, dark chocolate, or white chocolate. So it's obviously going to be about the different types of chocolate. Some of the cakes contain nuts. Okay, so we've also got nuts and no nuts. Right. The ratio of number of milk chocolate to cakes. Okay, now I'm going to write this down. So the ratio of milk chocolate to dark chocolate is 10 to 3. And the ratio of white chocolate to milk chocolate is 1 to 6. So you have to be careful here, don't you? Because it's white is 1 and milk is 6. Okay, so we've got that the right around. And it says of the milk chocolate cakes. Then okay, let's deal with this bit first. So I've got a ratio whereby I can't compare these two values because they're not the same. So a bit like a fraction, if I make it like a common denominator or a common number, I can therefore get my ratio in one term. So if I write it out here again, so I've got milk chocolate, dark chocolate, white chocolate. I'm going to multiply, in other words, scale up this ratio by 3 times. So that's going to give me 30 to 9. And if I scale this one up, well, I'm going to scale this one up by 5 times, which is going to be 30 to 5. And because these numbers are now the same, I can write it as one ratio. So in other words, this is 30 to 9 to 5. Now, crucially, I'm just going to get rid of this because there's not going to be a lot of space. So I've managed to get my milk chocolate, dark chocolate, white chocolate ratio. If I add these things up, 30 plus 9 is 39 plus 5 is 44, which means, what am I doing? Let's see where I'm trying to go. What percentage of the cakes contain nuts? Okay. So basically, I'm going to need the fraction of milk, of dark, and of white. So milk is going to be 30 44ths. I'm not going to simplify that because I need it later. Dark is going to be 9 44ths, and white are the remaining 5 44ths. Then, of those, I then further break them down into with nuts and without. So let's do a rough tree diagram. So I've got my milk chocolates here, I've got my dark chocolates here, and then I've got my white chocolates here. Then within that, I've got has nuts and no nuts. I'm using the complement symbol. Has nuts, has no nuts, and has nuts, and has no nuts. Wow, what a question. This question, by the way, it's not difficult. It's just about layout. It's very easy to mess this up. So I've done milk chocolates, white chocolates. So now, of the milk chocolates, the ratio of nuts to non-nuts is 1 to 8. So of the milk chocolates, I am 1/9 nuts. Now remember, what do I want? I want the percentage of nuts. So in other words, I want this number here, this number here, and this number here. So I don't care about the 8/9. Of the dark chocolate, so think about the dark chocolate, so I'm looking here now, the ratio of chocolate cakes containing nuts to not nuts is 3 to 2. So in other words, this nut is going to be 3/5. Similarly, looking at the final part, of the white chocolate cakes, the ratio of cakes containing nuts to non-nuts is 2 to 5. So this number here is going to be 2/7. And then I just need to multiply this out because I want the total of all these arrows here, in other words, all the cakes that have nuts in. So my milk chocolate is going to be the 30 over 44 I worked out above, times by 1 over 9. The dark chocolate is going to be 9 over 44 times, 3 over 5. And the white chocolate is going to be 5 over 44. So I'm taking all these numbers from the numbers I worked out to start with and multiply that by 2 over 7. Now, it's unlikely to be a calculator question. So I'm going to get my calculator out just so I get this right, which means I'm going to be simplified, but that's fine. So anyway, calculator out. First one, 5 over 66. Next one is 27 over 220. Again, the calculator is simplifying it, so it means the denominators are different, but that's fine. And the next one is 5 over 154. Now, I want the total percentage of the cakes that contain nuts. So if I add these fractions up, that gives me, well, the calculator says 97 over 420, so I'm going to write that down. So 97 over 420, but that's not a percentage, so I use my fraction to decimal button, and that tells me it's 23 point, well, it says 0.09523881, I'm going to call that 23.1%. And that is question done. Again, not a difficult question. It's just layout. You just have to be really good at laying things out nice and clearly. Good news is Edexcel gives you a lot of space, AQA less so, but AQA a lot of space. Just be nice and clear about what you're doing. Next and final question today. The first 5 terms of a linear square are 275. Okay, so first thing to do is I'm going to say the nth term of this sequence is 5n, goes up by 5, take away 3. So I've just done a basic linear sequence to get the nth term. Then it says a new sequence is generated by squaring each term of the linear sequence. So in other words, squaring this and adding 1. Prove that all terms of the new sequence are divisible by 5. Okay, so I'm basically going to work out what the nth term of the new sequence is. So what I'm going to do is take my 5n minus 3. I'm going to square it, then I'm going to add 1. And then what I'm hoping for is something with a 5 that falls out. So let's do that. So if I expand the brackets, that's going to be 25n squared. Minus 3 times 5 is minus 15, double it is minus 30n. Minus 3 times minus 3 is plus 9, plus 1 is going to be 10. And I can indeed factorise a 5 out, which is going to give me, not 2, it's going to give me 5n squared minus 6n plus 2, and answer the question. So I'm going to say as 5 is a factor, what am I doing? Proving that all terms are divisible by 5, so therefore divisible by 5. Now, as you may have heard me say in other videos, it's a lot looser at GCSE, so you get away with it being a bit less rigorous, but you've got to make sure you're answering the question at the end. Either way, question done. That was a nice mix of questions today. The indices questions were quite clever. That question in the middle was horrible, but equally it's a good practice of a layout. And the last one, not too bad at all. Let me know how that went for you. Do like, subscribe. See you tomorrow.